Hi, welcome to Finite Videos. This is DC here. In this video, I'm going to show you how to program PN5180 using Arduino. P18150 is connected to Arduino using the SPI interface. So this is what I'm going to cover in this video. You're going to understand how the SPI programming is done. I'll be using the library from GitHub. I've shown this library in my previous videos, and you can get this library from the following address. I'll also make this URL available in the bottom of my video. I'll be using the standard Arduino Ide, and I'll be doing the code walkthrough of the sample program that comes with this library. And I'm going to show you how some of these PN5180 commands are programmed. So I'll be considering few simple examples like the read register, write register, reading the Eeprom, and load configurations. So this is something a developer or system designer always wish for. So it's very good to have the PN5180 and the Arduino on a single board. You do not have to use lots of wiring and level shifters. So there is a device, very similar device, but that is for PN532 or NFC chip, and that's called a Arduino. You'll be needing the datasheet of PN5180, and within the datasheet we're going to see the most important section, that is how the SPI connection and this PN5180 interface works. So in my last video I mentioned about it is possible. I don't say it's possible. Now if you see any connection between Arduino and PN5180, you'll always see the level shifter. So you need a level shifter because the signals coming from the Arduino is 5 volts, whereas the signal required by this board is 3.3 volts. But what I have done is I have connected Arduino and this board directly without any level shifter. The reason I did this is because, so if you remember the older NFC chips like RC522 or PN532, so even though RC522 the input voltage is just 3.3 volts, we always connect RC522 directly to the Arduino board. So I try to do exactly like that, and I'm not very sure how reliable these type of connections are. So it is quite possible that we cannot run this board as it is for a long period of time because of for an excessive power consumption. So because there's something which is out of my knowledge, I cannot comment anything on this. So I'll be happy if this board works for me until I finish this entire video series. So if you know any pros and cons of connecting this directly, please leave some messages. That will be helpful for the other viewers. And also one more reason why you can do this is these boards are very reasonable to buy them. So you can buy these boards for less than £6 from internet. It's not a big money. Compare this with the proper NXP demo kit, which will cost you nearly 30 or 40 pounds. You can see the board I've connected. So I've got the Arduino, this is a very old Arduino Uno board, and the PN5180 board, and these are connected directly without any level shifters. The first thing you have to do is go to the GitHub to this URL and get the Arduino PN5180 library. So if you go here and click this and say download zip, I have already done that. Now I have extracted that library into a separate folder. You can see it's called PN5180, and this is a library, and you're going to unzip this inside this libraries folder. Now this is what you see here. If you double click, this is the content of the library. So there are two important files, that is PN5180, and these two files, these are the actual SPI programming for this board. Whereas these two files, this is an example of how to use ISO 15693 chip using this library. There is an example here, and this is what you're going to see. So all these things you can access using the Arduino Ide. Now here I've got the IDE. Usually what I do is, this is my my way of programming. I always change the preferences and I've set that folder as the sketchbook location. Now if you go to File and Examples, you should see an entry for this library, and this name of the library, and this is the example. Now I have not, you don't have to make any changes to run this example, because all these connections are exactly what's in this what's mentioned here. So the most important connections are, if you scroll down, so apart from the standard SPI, say you got a MISO, MOSI and SCK, you cannot make a different connection, because MISO, MOSI, SCK, they all go into a standard predefined pin numbers. Whereas the other numbers, other pins, they're all configurable. You got a chip select, that is pin number 10. Kind of, for Arduino Uno, chip select is also predefined to pin number 10. This is a busy line, and this is the reset line connect to pin number 7. Now again, if you go through this, this is as I mentioned before, this example uses ISO 15693 card. You get, when you buy this board, you also get an empty, a brand new ISO 15693 card. Now we are going to compile this. Now before you compile, I'm sure you're aware of how to set this COM ports, and my Arduino board is connected to COM4, and I've set this board to Arduino Uno. The compilation is done. I'm going to upload. Now upload is done. Now one thing I have to make keep in mind here is the speed of the serial monitor, which is set to 15200. I'm going to open my serial monitor. So if the connection is correct, you should see all these scrolling messages. Now I'm going to place this ISO card, and you can see it started to read. So we are able to, we can see that the connection is right, everything is working all right. The next thing we are going to do is understand how to program, how to send the SPI or commands through SPI programming using Arduino. So you have to understand what is going on in this library itself. This line is where you create an object of type PN5180, and the next thing is there is a call to method called begin. So we are going to see what the begin does. Then you got the reset. Then after that there is a command to read the Eeprom and to get the version number of the Eeprom. Then you get the version of the product. So this is basically to get the product version number. This information is stored in the Eeprom of this board. And next there is one more read memory, read Eeprom command to read the firmware version. And the firmware is 3.5 in this board. And there is one more read, Eeprom read to read the Eeprom version itself. Now after that, you'll have these are the commands for ISO cards. I'm not going to go through these commands yet. So because the main purpose of video is to show you how exactly the programming is done. So what you have to do is you have to first go to this folder and open these two files. These two files are where the actual program is done. So before you do that, there's something you have to understand the way the SPI programming should work. Now this is how the SPI data exchange is done. The documentation says you have to first assert the NSS pin low and send the data and wait for the busy line to go high and deassert the NSS, then wait for the busy low to go low. So this is the part of the protocol you have to follow, if you want to read or write to this board. Now I have already opened these two files, the 500 the header file and the CPP file here. In the header file, you get all the declarations for the register numbers. You got here some of the Eeprom addresses that are used in this program, and plus there are so many things here, but it takes some time to understand everything. And these are some of the methods available, and these methods they go with the commands of PN5180. Now there is a command called write register in the chip. There is a high level command called write register here. Now all the things you see here, they all correspond to a command in the board, but there are more commands in the datasheet which is not implemented in the library. But once you understand how these commands are written, you can add any number of methods on your own. Likewise, there is a method to turn the RF on and RF off. Okay, so if you go to p1580.cpp, now this is the NFC begin. Now if you remember, this is the first method that was called. Now this is the standard way of doing SPI programming. So what it does here is just setting the pins. You want NSS pin to be output, and these are the standard the basic Arduino programming. The busy line is input because busy line is driven by the P1580 board, and RST is an output. And here the chip select is set to high. This is how the initialization of the board is done. After that, you got a standard SPI begin, and also these are the standard SPI setting. So if you have seen the coding of PN532 or Arduino, or MFRC22, you'll also see a similar kind of settings. After that, you got so next is you can see the write register. Now first you're going to see how the write register looks like in the documentation. We have seen this bit in the last videos where I explained about various commands. Okay, so the write register, you have to send the command 00 followed by the register number, and you get the 4-byte output. Now let's see how this is done in the programming. Now there are so many statements like debug here. You can ignore them all. These are all, the main purpose of this is to show the debug data on the serial monitor. Now everything starts from here. So this is the command, the hash defined in this dot header file. So probably either it's here or probably it's defined somewhere. Most of the time you find these definitions in the dot header files. So this is 00. Now this is where the command bytes, or the command and the parameter bytes, are defined. You have the command 00, the register number which is passed as a parameter to this method, and this is I think probably we are looking at the write register here, but yeah, the best is to start with if you go with a read register, that would be better. Yeah, in the read register you're going to send the command code is 04 followed by the register address, and you get the 4-byte as the response. Now this is simpler and much easier as well. So search for, if you go to header file, the name of the method is read register. I'm going to Control C and say Control F. Now this is the method that does the read register. So these are the standard SPI programming in Arduino, where you start with the begin transaction, you set these parameters. So above that, this is where the 2 bytes. See, once it comes to the SPI programming, everything is a byte here. So we know the read register command takes 2 bytes. One is the command itself and the register number, which is passed as a parameter. And here this function passes one more integer variable, which will take the value of the register. So keep in mind there is a pointer, it passes a pointer. Now you begin the transaction. This is SPI communication start and SPI communication end. Within that there is one more method called transceive command. Now everything happens in this transceive command. So here you're passing the command and the size of the command, and also passing the buffer or the placeholder where the response is stored, and you're also going to pass how many bytes of response you're expecting from the SPI. So this is the very standard SPI programming. So it doesn't matter whether you program P5180 or PN5180 or MFRC522, this structure remains the same. Now if you search for this transceive command, now you can see everywhere in that's the only single, it's the most important function that's used here. Okay, now this is where everything happens, and the author of this program has mentioned exactly what the documentation says. So here this is the protocol. So you have to first wait for the busy line to low, this one. In fact, if you ignore this bit first, this is something which has to be done before every command is executed. If you follow the documentation there, it says assert NSS to low. That's the first step. There is a small delay after that. After that, perform the data exchange. This is the standard SPI programming where you transfer the data byte by byte. This is what's happening in the loop. Afterwards, it says wait until the busy is high. So this is a loop, an infinite loop that will wait for the busy line to be high. Once it is high, deassert NSS. The NSS set to low means deactivate basically. So here, by setting to low, you are activating. By setting high, you are deactivating. This is followed by a small delay of 1 millisecond. Afterwards, wait for the busy line to go low. So everything is happening here, the actual byte transfer, and all these signal setting high and low, they're all part of the protocol that's defined for PN5180. Now everything ends here. Now if there is no response for this command, then everything ends here. Because this is a read register command, so some more information is passed here. We know the buffer is passed and also the size of the buffer. Now this is what reading from PN5180. So this protocol again starts with the same thing. You make the NSS low. These 5 things repeats everywhere. So you have to set the NSS low. You read. Now this is how the SPI reading is done. So it looks like you're trying to transfer it. You're transferring the dummy data here, FFs, but eventually now you'll be receiving the response as well. So that is passed to this buffer. Then after that you got the busy set to high, wait for busy to high, then bring the NSS high, then wait for busy to low. So that's all. So after this function call, if you go back to for the read register, so read register here, the response is stored in this value. So next I'm going to go through this write register command. So here in this method you're going to pass the name of the ID of the register followed by the 4-byte integer. We know that the size of register is 32 bits in this processor. So these are the debug commands. Now this is the bytes that needs transferring to the board. So the command, the register number followed by 4 bytes, and these bytes are sent using the little ending where the lower byte is passed first. So the P0 is the lower byte of the integer and ends with the upper byte. So this buffer needs sending to the board. Again the process is the same. The SPA transaction starts and the transreceive is called. This time only 2 parameters are passed. That means there is no response. Now we'll be going back to the same command again. It's the same method and we have gone through it already. Let's go through this once again. Now this is kind of a safe way of programming. You wait for the busy to be low. When the busy is high, because when you've got a multiple PN5180 board connected to single Arduino, it's quite possible that the busy line could be high. The busy line is shared by probably by all the boards. Okay. Now it's the same thing. You first assert this to low, give a delay, then send all the data, here in our case 4 bytes, then wait for this to go high and wait for that to then deactivate the NSS, then wait for the busy line to go low. That's it. Now because we are passing no other parameters, the program terminates here. Now once you know this basic concept, then everything is about understanding the command from the datasheet, and you have to understand what type of data needs passing. Say for example, if you go and look at say Eeprom Read, so this is the command structure of Eeprom Read. The command code is 07 and followed by the address. The Eeprom has got 256 bytes, so you just need 1 byte of address, followed by the number of bytes you want to read. So now we know what is the command structure. The next thing is you're going to see how that is done in this library. So search for Eeprom. So you can see here there's a hash defined variable for Eeprom Read, and this is the Eeprom Read command. So the function takes the address, the buffer and the length, and everything is happening here. This is where you build the command structure. There are 3 bytes in the command, and next thing is, and I'm not going to go through this thing, it's the same. So build up all the bytes and send this here. Because you're expecting some response with the read, you have to pass the buffer and the length. So likewise, take any command. So I'm going to take one more command called the load configuration. So it's a command called load RF configuration. This is one of the most important command. Before you can communicate with any RFID NFC tags, you have to call this method. So this sets the transmitter and the receiver parameter, like the protocol and the speed and everything. So this command takes 3 bytes, the command code, 1 byte that tells the configuration byte and the receiver byte. Now this command is very comprehensive. these are the values you can pass. On the left side is the configuration you want on the transmitter side. The right side, I want the parameters you can set at the receiver side. Say for example, if you want to read a MIFI classic tag, classic tag, the protocol is ISO 1443A, the speed is 106, and the receiver is also set to this. So you'll end up passing the transmitter byte as 0 and receiver byte as 80. So if you're doing, say for example, ISO 15693 with ASK100, you'll end up using 0D on the transmitter, and you'll be using 8D on the receiver side. So like that, there are so many variants here, so you have to go through them and understand one at a time. So we're going to see next how this is done in here. So search for load. So load RF config. Now it takes 2 bytes as input, the transmitter configuration, receiver configuration, and this is where the command is built. It's just 3 bytes, and then everything is passed here. So like that, there is also a command called send data. Now this command takes it just sends the data, and it sends some number of bytes, and also tells what should be this tells about the last byte, how the last byte is sent, whether it's a full byte or whether a few bits are sent. So we're going to see how to use this command in my future videos, where I'll be showing you how to read and write various types of tags. So going back to this command structure, here you got the send data as everything is built up here, followed by just valid bit. So this command needs only it takes the 2 parameters followed by all the data bytes you're going to send. So here you have to make sure the buffer has got enough size. So the length tells you how many bytes you're going to send, plus 2, you need 1 byte for the command code, 1 byte for the valid bits. So once this array of bytes is built, the next thing is you have to start sending here. So here something different is happening. It's not just sending here. This is what we have seen before, but before that because this command, if you look at the documentation, it will try to send the data directly to the NFC tags. So in order to do that, you have to make sure these settings are done. Again, I'm going to explain more about this when I start showing you the NFC tags. Now one thing what you have to make sure here is, before you can send this send data bytes command, you have to make sure initially you make the transmitter in idle state, then you're telling transmitter to go into transitive command, and you're going to check the transitive state, that it's in the kind of a idle, or it's in the wait transmit state. After that you can send. Now once this command is done, probably you'll end up getting some responses. So it's really very simple to program PN5180. Now if you compare this with the PN532, you will not have any high level commands. So in order to read a MIFI tag, you have to start from the scratch, like loading the configuration file, sending all this the low level commands like REQA and anti-collision 1, anti-collision 2, and so on and so forth. Okay, so I think that probably this video has given you information so that you can start modifying this library. As I mentioned before, this library doesn't have all the commands that are mentioned in the datasheet. So with this background, I'm sure you can start adding your own functions. Alright, thanks for watching.